So this information that we just wrote down, class, can be helpful when we're solving these types of problems that you see on the right. Let's take a look and see how it will help us. If CD is an altitude of triangle ABC, find the missing measurements. So they tell us that triangle ABC has an altitude CD, which is perpendicular to the hypotenuse, and it goes up and it touches letter C. They want us to find the length of AB, CD, and AD. Now, some of you will understand this pretty quick and actually be able to solve it right now, but most of us have difficulty figuring out how all of these sides relate. So let's go ahead and write out all the relationships by writing our statements of proportionality. Once we do this, we should be able to figure out all of the missing sides. So the first thing we'll do is, let's write the statement of proportionality from triangle, or the large triangle, to the medium triangle. There's our first one. So here we go. Let's go look at our large letters. Our green is our large. The first triangle here, ABC, is our large. And our medium triangle was ACD. So let's look at our first line right here. We can say that AB over AC is equal to BC over CD, which is equal to CA over DA. So look what I did. I went ahead and just took the large triangle and the medium triangle, and I wrote my statement of proportionality. Okay, so there's large to medium. Let's go ahead and now let's do large to small. That was the next group we did, large to small. That was the blue. So now let's go ahead and write our large to small. So large to small, I'll put a line here so we can kind of divide these up. So large to small is AB to CB is equal to BC to BD, which is equal to CA to DC. Again, if you take a look at that, I used all the same thing we normally do for a proportionality statement, the first two, the second two, and then the third and the first, and made all of my different ratios. So there's large to small. Let's go ahead and draw a line there. And now let's go ahead and compare medium to small. So medium to small, that's the purple down here. Let's go ahead and write our proportionality statement. AC over CB is equal to CD over BD, which is equal to DA over DC. All right. Now this shows you all of the proportionality things that we have going on between these three triangles. We're going to use this to solve these problems on the bottom. So let's take a look. First question is, and just remember, class, if you want to draw a line right here, these three similarity statements are generating these three statements of proportionality. Okay, how do you find AB? Well, the first thing I notice is AB is part of my larger right triangle, and I already know AC and CB. And since that's a right triangle, you guessed it, we can use Pythagorean theorem to solve for this. So I'm going to make a little note just so you guys see this. This is going to be Pythagorean theorem. We can use that. I always use that when I can. So in this case, let's go ahead and write this out. We've got 15 squared. There is the AB, 15 squared, plus our other leg, which is 8 squared, is equal to our hypotenuse, which is AB. That's what we're looking for, our hypotenuse. Let's go ahead and label that as C squared. I'm going to scroll up a little bit here. Okay, so 15 squared is 225. 8 squared is 64. That's equal to C squared. You add these together, it's 285 is equal to C squared. Square root both sides, and you're going to end up with C equals 17. So right below this line you could write, so AB is equal to 17. And that's centimeters, 17 centimeters. 17 centimeters. There's our first missing part. Now the next part is, what is the length of CD? What is the length of CD? Let's take a look. CD is our altitude. Now what you want to do, class, is just like you normally do when you're using statements of proportionality, find where the missing side is. Here's CD, you can see it right here. Here's CD right here. Here's CD right here. And find another proportion that you know both measurements. Let's take a look. Do we know AB? Yes, we do. We just figured it out. It's 17. So I know AB. I'm going to put a little mark here. I know that one. And do I know AC? Yes, I do. I know AC. Okay. I'm looking for CD, which is right here. And I also know what CB is. So take a look. I just found my two ratios that I can use to find the length of CD. There's probably another one in here somewhere that you can use, but we found it in the first two. So let's write these down. We've got AB. Our proportion is going to be AB over AC is equal to BC over CD. So let's plug in what we know. AB is 17. We just figured that out. So AB is 17. AC is equal to 15. BC is equal to 8. And CD is what we're looking for. That's our unknown. Let's cross multiply here, and we end up with 17x is equal to 15 times 8. And if we multiply that out, we're going to end up getting x equals 7.0 something, but it rounds to 7.1. So now we can say, so CD is equal to 7.1 centimeters. So now you can see we've got all these statements of proportionality that we can use to solve these problems. Let's take a look at AD. We're going to find AD. I'm going to change colors, and let's see if we can find ratios that will help us. AD is actually right here. And you know what? If we're looking for AD, do we know what CA is? Yes, we do. We know what CA is, and we know what AB is, and we know what AC is. We just found our two ratios. These two and these two. So let's write them down. We're going to use AB. I'm surprised I didn't have to use these other ones, but this worked out. AB over AC is equal to CA over DA. Let's plug in what we know. AB is 17. See, you can hear a train in the background, class. AC is 15. CA is also, it's the same thing. CA and AC, that's also 15. And DA is our unknown. Let's go ahead and cross multiply. So we've got 17x is equal to 15 times 15. If you multiply that out, you're going to get x equals 13, about 13.2. So we just found, so AD equals 13.2 centimeters. Now, class, just one more thing. I should be using approximately 13.2, approximately 7.1. I've been forgetting to do that, but for the case of this question, it's okay if we round it because we're not going to give exact answers on these questions. So there's an example of how to use the three triangles created by the altitude to a hypotenuse of a right triangle. Since all these triangles are similar, we can use all these statements of proportionality to find all the different missing sides. And we could actually now find DB as well, and that would give us every single side of this particular diagram.